Welcome to www.happynumbers.org. Today's lesson is going to be solving algebraic equations when we have like terms on both sides of an equation. On both sides of an equation. And here's an example. 3 times x is equal to 2 times x plus 7. Well, we have two like terms here, but they're on different sides of the equation. And our approach when we're working with equations is always the same. We want to get the unknown or variable on one side and all the numbers on the other side. Well, I have a 2x over here, so I want to get the x's over here. And this is a positive 2x. So I can add the inverse or opposite. So I can add a negative 2x here. And if I add a negative 2x on this side, I have to do the same thing here. Because whatever I do to one side, I have to do to the other side of an equation. Well, now if I combine these, I have a positive 3x and a negative 2x. Well, that'll just give me x, a positive x, equals. Now, if I combine a positive 2x and a negative 2x, that goes away. So I get x equals 7. Let's go back to our initial equation. It said 3 times x equals 2 times x plus 7. Well, let's substitute 7, which is x, in our equation. 3 times x, which is 7, is equal to 2 times x, which is 7, plus 7. Well, 3 times 7 is 21 equals 2 times 7 is 14 plus 7. Well, 14 and 7 is 21. So 21 equals 21. So our solution, x equals 7, is correct. All right, let's just review this again. I had 3 times x equals 2 times x plus 7. My strategy or approach is just like solving any other equation. I have to get all the variables on one side and the numbers on the other. Well, I have a 2x here. It's a positive 2x, so I had to put a negative 2x using the opposite or inverse, and if I do that on this side, I have to put a negative 2x. Then when I combine a positive 3x and negative 2x gives me x. These two go away, and I'm left with x equals 7. Very simple skill set. Let's take a look at another problem here. Let's take a look at this one. 2y minus 6 equals negative 3y plus 24. Interesting problem now. I have like terms on both sides of the equation, and the numbers are like terms also. So, first of all, let's deal with the 3y. I want to bring it over to this side because I have to get all the variables on one side, all the numbers on the other. Well, I have a negative 3y, so I can put a positive 3y. And of course, if I put a positive 3y here, I have to put 3y here. So I'll combine my y's. These are like terms, so I can combine them. 2y and 3y gives me 5y minus 6 equals, well, if I combine the negative 3y and a positive, that goes away. So 5y minus 6 equals 24. Now, I have 6, and I need to get the 6 over here. It's a negative 6, so I can use the inverse or opposite, which is positive 6. Positive 6, I have to do the same on this side, and I get 5y. The negative 6 and positive 6 go away, equals 24 plus 6 is 30. Now I want to go eliminate the 5, and this is multiplication, so I'll divide by 5, divide by 5. Whoops, a little sloppy there. Supposed to be a 5 here. Well, these 5's cancel out, and I get y equals 30 divided by 5, which is 6. So I have solved for y, and y is 6. And if you went back into the initial equation and substituted 6 for y, you would come out that everything on one side would be equal to everything on the other side. Well, let me put up a problem for you to work here now. You should be getting quite skilled in your ability to solve equations. So let me give you one that's not really too bad, but it's not just an easy one. Let's do this. 9b minus 7 equals 5b plus 25. All right, so put your DVD on pause, work that problem, and then turn it back on and we'll look at it. Okay, let's see what we have here. First of all, we have two like terms, and they're on opposite sides, so I would like to get the 5b over here, and this is a positive 5b, so I'll put a negative 5b, and I have to put a negative 5b here. Because what I do to one, I have to do to the other. If I combine these, 9b minus 5b, I get 4b. Minus 7 equals, the positive 5b and negative 5b will cancel out, and I get 25 here. Now I have myself a negative 7 here, and I want to bring it here, so I can use the opposite or inverse, so I'll put a positive 7, and I'll get 4b, and these will cancel out, equals 25 plus 7 is 32. Now I want to get b all by itself, and this is multiplication, so I'll divide by 4 and divide by 4. The 4's cancel out, and I have b equals 32 divided by 4, which is 8. Well, good.